Okay, we have a boat on a lake. We're going to ignore any friction. The friction is going to already be swallowed up in these values. So the boat on the lake has an initial velocity of 8 meters per second at 40 degrees north of east. The boat has an acceleration of 2.5 meters per second squared at 20 degrees south of west. What is the velocity of the boat after 5 seconds? This is not projectile motion. This is not a ball flying through the air. This is happening on a horizontal flat surface. Yeah, it will end up turning, definitely.
Is that what's turning the acceleration?
Yeah.
Okay, that makes sense now.
So that's our velocity vector. 8 meters per second, 40 degrees north of east rather. So I'm using the traditional north, south, east, west coordinate system. So 40 degrees north of east will put us up in the first quadrant. The acceleration (2.5 meters per second squared), 20 degrees south of west. So it's going to cause the boat to slow down, and it may or may not turn around by the time 5 seconds has passed. This problem is acceleration constant. Yeah. Has a value of 2.5 meters per second squared, angle of 20 degrees south of west. If acceleration is constant, the kinematic equations apply. We're told the time of 5 seconds. So we know time. Where would you like to put the origin?
In the middle.
Right where it starts, where the boat is has this velocity. Sounds good to me. We don't know where the boat ends up. X and Y final, we don't know. The initial velocity in the X and Y direction. Exactly. Initial velocity in the X direction will be 8 meters per second times the cosine of 40. That's 6.13 meters per second. The initial velocity in the Y direction will be our 8 meters per second times the sine of 40. So 5.14 meters per second in the Y direction. What about Vx and Vy final? Do we know those yet? No. That's actually what we're looking for. What will the velocity of the boat be after 5 seconds? Well, that's going to depend upon the final X and Y components of velocity. Why is this not 6.13?
Because acceleration is not zero.
Right. Now there's an acceleration. Our acceleration this time has an X and a Y component. The acceleration in the X direction, the X component, is headed to the left, so it's going to be negative. So negative 2.5 meters per second squared times the cosine of 20 will be our acceleration in the X direction. So negative 2.35 meters per second squared. this acceleration vector points downward, so this acceleration in the y will also be negative. This time sine of 20. So negative 0.86 meters per second squared. To describe the final velocity, we need to know the x component finally and the y component finally. We need both. We know initial x position, we know initial velocity, we know acceleration, we know time. We're looking for Vx final. That equation will come in handy. Relates the velocities, acceleration, and time. Our initial velocity in the x direction is 6.13 meters per second. Our acceleration in the x direction is negative 2.35 meters per second squared. Our time is 5 seconds. Negative 5.62 meters per second. So after 5 seconds, at least in the x direction, it's headed to the left. So it's headed west. Now for the y direction, we can use the same equation, but with the y information. So 5.14 meters per second plus a negative 0.86 meters per second squared times our 5 seconds. .84 meters per second. So our velocity has an x component to the left of 5.62 meters per second, but it's still headed north at this instant at 0.84 meters per second. So our velocity vector is a little bit north of west at this moment in time. To find the magnitude, how fast, 0.84 squared plus 5.62 squared, square rooted. .7 meters per second. So it's traveling, at this moment in time, it's traveling at 5.7 meters per second. Angle inverse tangent of 0.84 over 5.32. Sorry, 5.62. This little angle right here is 8.5 degrees. But we need to clarify north of west. Or you could subtract it from 180 and just write it as 171.5.